All right, so we're gonna get this meeting going. It's 11:30. Thank y'all all for joining us today. We are going to start with our business meetings for the Dallas and Fort Worth section. So I'll kick it off with the announcements for the Fort Worth group. We have started our officer elections for people who have not had that opportunity to go vote yet. The voting ends Friday, December 4th. That is the Friday after Thanksgiving, so get your votes in. Our candidates are for Vice President and President-elect is Brendan Wheeler. Secretary Treasurer position, we have Alex Garcia and Lee Williams. And for our section representative is Mark Mathis. And then we will also be hosting our section annual business meeting on December 10th, 2020. So I'll pass it over to Pam for the Dallas announcements.
Thank you, Jennifer. So I have 5 quick announcements for the Dallas section. The first one is about our 2021 officer election. So we're in the middle of it. Just like Fort Worth, our ballots will be open through December 4th. So if you haven't voted yet, please make sure to vote. If you are a paid member and you're having issues receiving it, just let the officers know, send us an email. We have 2 great candidates for the secretary treasurer position. We have Brian Shusky with the city of Plano and Ramon Deniconda with the city of Richardson. So thank you both very much for your willingness to run. We're very excited for whoever is going to be chosen and be part of the team. Running for vice president, president-elect is Chad Ostrander with BGE. Again, so make sure to vote by the 4th. We have a call for 2021 committee volunteers. So anyone that wants to get more involved and participate, we definitely want to hear from you. So make sure to email the officers at dallas@techsite.org. You can see all of our committee chair positions on our website. If you go under About Officers, just scroll down and you can look at the list. A lot of our current committee chairs are definitely going to come back, and we're very excited to come back for them to come back and help us out in the year. But we definitely want more people to get involved and new ideas, especially since we're in this virtual world. We want some fresh ideas to how do we interact with our members virtually. Second announcement, the 2021 class of leadership ITE. So I wanted to quickly congratulate Josh Smith with Lee Engineering. He was one of 4 Texas district members that was selected. So congratulations, and thank you for representing the Dallas section, Josh. Our annual business meeting will be on December 11th. This will be the last meeting of the year. It's crazy. We're already at the end of the year. But mark your calendars, and we will be sharing more details in the near future. And then the fun part is we are about to hand off some scholarships to students. And before I hand it off to Rhett to make these announcements, I quickly wanted to thank him. So Rhett Dollins is with Maldonado Burkett. He's been the scholarship selection chair for 2 years now, and he's done a fantastic job. So thank you so much, Rhett. And I also want to acknowledge the reviewing committee that included Matt Tilkey with the city of Plano, Carl LaFernie with Pacheco Coke, Ana Cervantes with Othon, and Hanek Tazera with Kimley Horn. So thank you everyone that put in the time to review these applications. And before I hand it off, thank you for all of the sponsors. Rhett will make sure he acknowledges each and every one, but thank you everyone for making this happen. We weren't able to put on our traditional golf tournament like other years, but these sponsors helped us and made sure that these students were able to receive a scholarship this year. So thank you. With that, I am gonna hand it off to Rhett.
Thank you, Pam. Appreciate it. And I'll echo the thanks to the selection team, Carl and Anna and Henok and Matt. Appreciate all the help with reviewing these scholarships, and I do appreciate all the effort that was put in. So, Pam, if you have the photos of the slides for everyone. We do have some photos of the recipients holding their certificates. Unfortunately, we were not able to do it in person this year, but we do have some photos, which is the next best thing. So our first recipient for this year is Devon Narayan. He is a student at the Honors College at the University of Houston studying civil engineering. He is expecting to graduate next month. So congratulations to him for that. That's a big step. One of the things that he mentioned in his application was that in addition to studying civil engineering, he does enjoy officiating sports events, specifically football, and he hopes to become an official in high school athletics after he's gotten his degree all said and done and his career settled. That's what he's going to be spending his Friday nights doing. He has been an intern for the last 2 summers at BGE Incorporated, and so we congratulate him on his award of $1,000 for a scholarship this year. His scholarship was sponsored by 3 companies, WSB and the 3 Bryans. I don't know if we should call them a company, but the 3 Bryans helped sponsor that scholarship, and also Othon Incorporated was a sponsor of the scholarship. So thank you to all of those sponsors, and congratulations to Devon. Our next recipient is Afshin Shamshuli. He is a PhD candidate in electrical engineering at the University of Texas at Arlington. His area of study is in development of a system or platform that can detect air quality measurements in real time, which is obviously very relevant to the transportation engineering field. So he has been working on that for the last year or 2 over there at UTA. He has completed all of his coursework at UTA and is now working on his dissertation with an expectation to be completed in May of 2021 with his PhD. He does have a 4.0 grade point average in his graduate classes, which is very admirable. So congratulations to Afshin for an award of $1,000. And this scholarship is sponsored by Paradigm Traffic Systems. Thank you to Paradigm, and congratulations to Afshin. Our next recipient is Shida Kademi. She is also a student at the University of Texas at Arlington. She is working also on a PhD with an expected graduation date of August 2021. She works as a graduate researcher at UTA, and she is active in several extracurricular activities. She's active in ITE at the student chapter, and she also attends some of the national chapter meetings. She is a member of Chi Epsilon. She's a member of the Society of Women Engineers, WTS, at UTA. And she's also active in other extracurricular activities. Congratulations to Shida for an award of $1,200. This scholarship was sponsored by Jacobs Engineering and Lambeth Engineering Associates. Thank you to our sponsors, and congratulations again to Shida. Our final recipient this year is Shirin Kamali Rod. She is also a student at the University of Texas at Arlington. She's working on a Master's of Science degree in Civil Transportation Engineering. Her expected graduation date, again, is next month. So congratulations, Sharon, on that accomplishment. She works as a part-time research assistant at the University of Texas at Arlington. She's also involved in several extracurricular activities. She's involved with the ITE student chapter, the American Society of Civil Engineers, Chi Epsilon, Women in Transportation, and also the Persian Academic Cultural Society. Congratulations to Sharon. This scholarship was sponsored by Durable Specialties Incorporated. So I'll say again, thank you to Durable Specialties for the sponsorship, and congratulations to Sharon. That is all the scholarships that we have for this year. And so I will turn it over to Joe Marcioni.
All right. Thanks, everybody. I'm here to introduce our speakers for today. Our topic is saving lives by runway detection and warning systems. Our first speaker will be Jessica Miramontes. Jessica graduated from the University of El Paso with a master's degree in transportation engineering. She has been working as a traffic and ITS engineer with Kimley Horn for almost 5 years. She is currently a registered professional engineer in the state of Texas. Her work experience consists of ITS design projects and signal design. Her experience has been focused on public agency projects and involving advanced traffic management systems design, ITS and communication master plans, ITS, PSV package, and PSV packages. She recently completed runway driver system projects for the San Antonio District of TxDOT and the North Texas Tollway Authority. Our second speaker will be John Gianotti. John is the TransGuide Operations Manager at the San Antonio District of TxDOT. He is responsible for the design, construction, and maintenance of the ITS infrastructure, CCTV cameras, DMS boards, and fiber optic network. Manager of the TxDOT San Antonio HERO program, the San Antonio Runway Driving Program, and the San Antonio Traffic Incident Management Group. And with that, I will hand it over to Jessica.
Hello, can you see my screen?
We can, Jessica.
Okay, perfect. Okay, perfect. Okay, thank you for the introduction, and thank you everyone for being virtually here. It is a pleasure to be able to present about this topic, saving lives by runway detection and warning systems, the design and the implementation. This is the agenda that we will be covering today. I will be covering some of the facts and why this system is important, how the system works, and the design overview. Also, we will be presenting 2 case studies, one for NTTA and one for the TxDOT San Antonio District. Okay, let's start discussing the problem. So this is a slide from the CAD initiative from TxDOT that stated how many people lost their lives on TxDOT highways in 2018. Also, this graphic presents the percentage of the factors for the fatalities. As we can see, the human factor play a big role, and runway driving fatalities continue to rise year over year, but it can be mitigated with a runway driving detection system. According to TxDOT, there were about 1,000 runway collisions in 2019 with 67 fatal crashes. Most of the runway drivers involved in collisions were suspected or proven to be intoxicated. And this is one of the TxDOT Vision Zero emphasis, the impaired driving as a target. The TxDOT San Antonio district is heavily involved with these systems deployments and have been seeing almost a 30% reduction on wrong-way driving events since implementing. Here are some of the benefits. Cost savings resulting from the reduction in crash response time, and also result in cost savings from damaged infrastructure. Also increase safety and mobility, and also it saves lives by alerting a wrong-way driver and allowing them to self-correct without potentially causing a collision and risk the lives of other people and themselves. This is how the system works. First, it detects the wrong-way driver, then alert them to give them the opportunity to correct themselves. Also, the system alert the agency via email or text alerts. If the driver corrects themselves, then the agency receives an alert that has been resolved. But if the driver do not correct themselves, they can take action, such as to dispatch authorities and to notify right-way drivers to be alert using existing dynamic message signs or by vehicle to infrastructure communication. The design features varies by size and by client. There is no one size fits all solution. You must get to know your agency policy. For example, NTTA is different than TxDOT in terms of implementation of different equipment. It is important to analyze each site depending of the geographics of the site and needs. The site consists of warning signs, detection, power, and communication. So this figure, here you can see there's a pole. So here is where the detection will be installed, and it will be detecting the cars going the wrong way. Once it detects, the system activates, and it gives the opportunity to the wrong-way driver to correct themselves. If that doesn't happen, there's another detection zone called confirmation zone, and then the agency can act or do either alert the right-way drivers or send the police. So here in this table, I show the different kind of features that you can get on those designs. The warning signs can be static signs with flashing LED signs, like the picture. It can be static signs with flashing beacons or with rectangular rapid flashing beacons. It can also have LED RPMs and audible notifications. For the mounting of the signs, also it may vary. It can be installed on a existing signpost, or it can be on a new signpost, or it can be installed in new pedestrian poles. For the detection, also varies. You can use thermal cameras. You can use radar detection pods, and you can have CCTV cameras to capture confirmation videos. For power, it can be solar or conventional power for the whole system, or it can be solar only for the warning signs and conventional power for the detection pole. It can mix based on the needs and also the geographics of your site. For backhaul communications, it also varies between cellular, wireless, and fiber. The backhaul communications means the communication to your agency network, but also the detection pole needs to communicate to the warning signs to activate whenever there is an event, and that can be hardwired or wireless. This picture shows the difference between the thermal cameras and regular cameras. As you can see, it is better to see when there is sunlight or an obstruction or at night. And taking into consideration that 78% of the runway fatal crashes occur between 6 p.m. and 6 a.m., it is important to see at night, and thermal cameras are better at it. Colorado DOT and Arizona DOT recently did studies comparing the various technologies and agree that thermal cameras provide the most effective detection under the circumstances that these events may occur. Thermal camera is consistently deployed right now, but also radar is fairly reliable. They began using only one unit, and recently they added a second radar unit to combat false calls. As I mentioned, it depends on every site and their unique needs. Regarding the price of the different designs, it varies by each design feature. It can be as simple or as complex as you may need. Here I will present different scenarios to show how low it can be or high cost range it can be. So for scenario one, this is scenario one. I'm presenting a very simple design with static signs with embedded LED, mounting in existing signposts, and everything solar to the system. Then scenario two, it's a little bit more complex. It will be static signs with with embedded LED mounting on new pet poles and solar to warning signs and conventional power to the detection pole. And then scenario two will be using static signs with rectangular rapid flashing beacons, new pet poles, conventional power, and hardwired communication within the system, and fiber communication to the agency network. Here, I present which features have for each scenario. I listed all the characteristics for each of them, and as you can see, the cost varies from 17K to 60K. So you really need to study each of your sites. Maybe your most simpler scenario will satisfy your needs, but if you have a higher conflict area and you really need to invest a little bit more, you will need a higher cost scenario. Okay, now I will present this case study about the first runway detection system for NCTA that we helped them design last year. They installed the system this August and are currently under evaluation of the system. This design made it to the news on September, stating that the problem and how the system will help to mitigate runway driving collisions. It may be hard to read, but it's saying that in April, 3 people died involving a runway crash in DNT, and 3 months later, another 2 a person died on the same type of crash. NTTA has been very active on studying runway crashes. They form a task force to create and deploy methods to reduce runway driving and crashes. Under that task, they install low-cost measures, including raised pavement marking arrows, additional runway and do not enter signs. And also they install runway signs with solar power with flashing LEDs, but without detection. Prior to using thermal cameras, NTTA experimented with detecting runway drivers using standard roadway cameras, but the glare from the headlights at night caused false alarms, making the system unreliable. Okay, this is the location where we designed the system. This location is at the south end of the DNT that probably you are familiar with. So here is DNT. So if you're coming south towards the end, you probably see this exit, the Harry Hines Boulevard downtown exit. So if you take that exit, you will see the site and you will see the problem too. So here, if you took that exit, you will enter here. So here it's 3 lanes merging to the Harry Hines Boulevard. And in the Harry Hines Boulevard, you have a signal here. So you have another 3 lanes. So you have 6 lanes one way. So what happened here is people that are coming to the signal and they're not familiar with the site or they're not paying attention. If they're coming this way and they wanted to go back, they do a U-turn here, and then they are entering to the DNT on the wrong way. Another problem is that people from this other signal, Wolf Street and Harry Hines, that are coming here and making a right, they are into the wrong way and entering the DNT. That being said, this design was really unique and it has these unique features. We had 2 sets of warning signs with rectangular rapid flashing beacons. We had new ped poles. We did have a 30-feet pole with a mast arm, thermal camera detection, conventional power, hardwire within the system, and cellular connection to the network. Okay, so this is the detection pole that we designed. The pole was initially intended to be a luminar pole with a radar detection at first, but due to the high runway detection incidents that happened here, we updated to be a mast arm to cut more attention to the drivers. Here it's the cabinet facing the other side. Here is the detection, the thermal detection. And for this instance, NTTA wanted to have their own equipment, such as more detection and a CCTV camera for their own. So here, also in the table, I explain which type of features the system had. So this is how the system looks installed. So here's the 30-feet pole with the mast arm with 2 warning signs mounted on the mast arm. Here is another pole, and then it's kind of hard to see, but we have another set of ped poles with warning signs as well. Here are the other two warning signs that were hard to see in the other picture. And this is how it looks at night when it's activated. As I mentioned before, Entity 8 is still under evaluation of this site, but within the first 4 days of installation, Entity 8 saw 6 events resulting in self-correction. Here, here I have a video to show how the system detects a car going the wrong way. Coming from the Harry Hines to DNT. So there it's doing the U-turn, and then the system detects it and it activates, and he notices, and he's going back. Okay. Is it playing? No. Okay, I think it's playing. This is another self-correction from Harry Hines and the Wolf traffic signal. Also, the system detects it activates the system, and he notices, and he's going back. With that, now I will pass it to John to cover some of the success of their system and a little bit about the I-35 project that we are working together. John, do you want to take control?
Sure. Thank you, Jessica. And I'd just like to say thank you for TxDOT for inviting me today to talk about wrong way driving. The picture on the screen you're seeing right now on the right side is a picture of the reports of 2019 wrong way drivers in San Antonio. And if you've been to San Antonio, we've got 2 loops, and the inner loop there is loop 410, and the outer loop, the circle, is loop 1604. And what you can see from this picture is wrong way driving occurs everywhere. There are certain hot spots that we're familiar with. We've been tracking these numbers since 2011. Like I said, this is the 2019 data. These hot spots and where it occurs change every year, but as you can see, this is not an isolated incident. It can happen pretty much anywhere, and that's just what I wanted to show with this picture is you can definitely identify spots like Jessica was talking about there in Dallas, but I'm sure if Dallas had the data that we did, they could drop a similar heat map and you'd see that it's a very scattered problem. So it happens everywhere all the time, much more than we would like to think. Let's see. Don't think I have control, Jessica. It's not wanting to.
Okay, I can advance.
Okay, there we go. Next slide. Okay. So this is the number, I call it saving lives. We've been tracking these numbers since 2011. These are the number of wrong way drivers that we have caught on our cameras, and with San Antonio Police Department's help, they have been able to stop on the highway, preventing a serious crash. So in the 9.5 years, SAPD has physically stopped 83 people on the highways in San Antonio, saving lives. And I've always told people these programs are about saving lives. And I've always asked people, if I told you that we were going to save the life of your mom, dad, brother, sister, wife, husband, pick whatever family member you want, and I told you we could save their life, and I asked you how much money would you give me, most people would, give me every cent they had. So this shows the success that we've had with our program here in San Antonio. We're very proud of it. We know we've saved probably more than 83 lives. That's assuming 1 life per crash. But we know we've had over the years several crashes that have had multiple fatalities. So this is a very serious issue. The problem with wrong way drivers is when you have a crash, they don't happen very often, but when they do, they're usually head on. They usually involve fatalities, or if they're not fatalities, very serious injuries to people that change their lives forever. So this is just a record and shows you what we've been able to do with the help of our partner agency, San Antonio Police Department. Next slide, please. Okay, we have several different systems here in San Antonio. The picture there on the left is the very simple flashing LED sign that TAPCO did. That's what we started with on our US 281 corridor. Those are very easy to install. You just take out the existing wrong way sign and replace it with a flashing LED wrong way sign. And then over here on the right side, we have a traffic comm system that we have up on US 90. Very complex system, has a couple of radars, video, LED flashing signs. You can see the video camera there with a radar detector. The big green box is the battery box. You can see the solar panel up there. These are installed on OSBs or overhead sign bridges at the exit ramps if we have them. If you don't have an overhead sign bridge, you can add this system to a PED pole, basically just like Jessica was describing previously, and pretty easy to install. Like I said, PED pole is pretty standard item. You just stick that on the side of the road. You can attach all of this equipment to a PED pole and fairly easy to install and maintain. Next slide, please. So we also have a TAPCO FLIR system, kind of like Jessica was describing there in Dallas. There's a picture there down the left showing one of our installations. We have 2 of these up now. The one that we worked with Kimley Horn on that Jessica was mentioning, there are 18 different ramps we're going to getting these installed on. The big picture on the right shows the FLIR camera up there on top of an overhead sign bridge. When you have an overhead sign bridge like this at an exit ramp, it makes it very easy to attach anything you want to it. You can see that FLIR camera up there. I've circled it. Those cameras are about the size of a softball. In this picture, it looks really tiny, but that camera is, the picture on the bottom left is what that camera sees. And in the background on the ramp, you can see those wrong way signs. Those are the signs that activate when this FLIR camera detects a wrong way driver. We've actually had 2 detections on this ramp. We haven't had a crash associated with that. And after they go past this camera, we don't have a second camera to detect, whether they've self-corrected. But the 2 wrong way drivers that we did detect on this ramp, we never received a report of a wrong way driver with SAPD's 911 system. And we didn't have a crash reported. So it concludes me to believe that these people went up this ramp, figured out they were going the wrong way, and probably self-corrected on the highway. But it does give us an advantage where we know when we get these alerts that we can then coordinate with SAPD and their dispatcher that's located with us here on our TransGuide operations floor. We can tell them, hey, we know a wrong way driver is coming up 35. They're going, in this case, it would be southbound on the northbound lanes, and we can tell them they got on at the McCullough exit. So that gives us a tremendous advantage when we can tell PD where and when to start looking. We know which direction they're going. We start looking with our CCTV cameras, and it saves a lot of time for us trying to detect the wrong way driver on our cameras in real time. So then we can follow them, and that's how we help SAPD find these wrong way drivers and stop them as quickly as they can. Next slide, please. This is another system, TrafficWare. They have pods that you see here in the middle picture. It's a little pod. That pod is about, size of a big hockey puck. You can see the person installing it there. We have 2 locations here. These pods are normally used for detection of traffic signals to detect cars. We just put them in the pavement to detect wrong way drivers coming up the pavement. And you can see in the picture on the left, the little black circles, those are the pods. We put 6 of them in one location. I think we put 9 of them in another. You can see the equipment here on the side. There is a camera that also reports back to us here at TransGuide via cell modem. Get an email, we get detection. There's a antenna, the big square up on top that gets the signal from the pods in the pavement to that detector. And all of this is radio controlled between the pods and the detector. And you can see again, everything's sitting there on a PED pole. So you just get your standard PED pole and you can attach a lot of equipment on a PED pole, which makes it easy. These work the same. Instead of with video or radar, the pods in the pavement are your detection. But after the detection, basically it all works the same. We get a video or snapshots of the wrong way driver, and you can see the wrong way signs in the background. Those activate when the detection's made. Very similar to what Jessica was showing in Dallas. So there are a lot of different companies. The detection is kind of different, but how it operates after that is the same. The lights go off, we get a video. We then can try and look for them with our cameras and follow them and alert PD. We can also, at that point, post messages on our DMS boards alerting the drivers on the road that a wrong way driver has been detected. So a lot of it after the detection is fairly similar, but there are several different companies now that are coming up with different ways to detect, whether it's radar, whether it's FLIR cameras, whether it's pod detection like this. After the detection happens, what happens after that is fairly similar. Next slide, please. So on our IH-35, we had some funding that we got for wrong way driving detection, 18 ramps on IH-35 on the south side of town. Combination of existing poles and putting up new PED poles and other poles that we needed. We like to have conventional detection. Conventional power is the best way to go if you can get it. It also works with solar. And all of them are based on cellular communications for our I-35 job. Next slide. So this is, if you know San Antonio, these are the 18 ramps that we had funding for, kind of starting 410 there on the south side is the inner loop, and it goes all the way down here to 1604 on the south side. And those are the 18 ramps that we had where we're going to install these FLIR detectors and wrong way flashing LED signs. They will be powered by cell modems, which will get us an alert and an email back to us here at operations at TransGuide, and then we'll be able to take it from there to alert SAPD to tell them, like I said, once we have the detection, we can tell them they're going the exact location and which direction they're going so SAPD can scramble their units in the field to go after them. Next slide, please. This is kind of basically a little bit similar to what Jessica was showing, what they did up in Dallas with NTTA. You have a PED pole, you have your cabinet here with all of the equipment you have in there. You can have 2 FLIR cameras, you can have CCTV cameras, several different versions of what you have and where you have it. Like I said, these can either be solar powered. We like to have the AC power, or I call it real line power on these for all of the cameras. That's the most reliable. But if you can't do that, you can obviously do this with solar power. But put a PED pole up, you put all your equipment on it, and you're pretty much ready to go. Next slide. So this is kind of another detail of what you can put on a PED pole, or for these, the picture there on the left, if you're just putting up the flashing LED sign, if you have an existing sign pole that just has a wrong way sign, you can replace that wrong way sign with a flashing LED sign and a solar power unit on the same pole that you have a wrong way sign. So you would not necessarily have to put up a PED pole. We've done this a lot in San Antonio, where we're just putting up the flashing LED signs where they continuously flash at night. You don't need anything special. You can just pretty much replace things and put things on additional poles. Or over there on the right, what we've also done is if you have an exit sign that's got 2 poles, you can put a wrong way sign on the back of those exit signs. You can also put radars on these, and you can put a little bit bigger battery backup on these with solar power. But you can work. This is the kind of showing the option where you have existing poles, or you can put up new sign poles. You don't always have to put up a PED pole. A lot of these things, if they're just signs, you can use your existing infrastructure to attach a lot of these things, and it works fine and it helps save costs. So funding for these, HSIP program, you can get a lot of funding from that. The one that we got on this one was Road to Zero funds. There were some leftover Road to Zero funds that we're funding this I-35 project on. The STEP program, you can use that, or a lot of the way that we do in San Antonio is we put a lot of our wrong way driver infrastructure in on existing highway PS&E projects, which is Category 1 funding. And depending on what we put up and depending on the cost, if you have a $50 million or $60 million roadway project and you say, hey, I want to put in, $100,000 or $200,000 worth of wrong way driver, they usually agree because it's such a small percentage of the overall highway project that there's usually not any issue with funding, and we can get a lot of stuff put in on roadway projects. So that's the way we've done a lot of our wrong way driving infrastructure in San Antonio, is we put them in on existing highway projects, but you can see the other funding sources that are available here to you. Next slide.
Okay.
I think Jessica, it's back to you.
Yes. Thank you, John. Okay, here it's a slide also for the CAD initiative from TechSide, and it's showing how the system it's incorporated to the infrastructure to vehicle technology. So here it detects the incident and it alerts, send a message to the wrong way driver that it's going the wrong way. And then it sends via the infrastructure to vehicle communication the alert to the right way drivers so they can be alert that there's a wrong way driver alert ahead so they can be more precautious. Here it's a video from TAPCO how the system is implemented on the connected vehicles interface. Let me, okay. So here the car is going the wrong way and the thermal sensor is detecting the wrong way vehicle, and it gets the signal to the connected vehicle interface via the roadway side unit, and those are the message that you will get. If you are the wrong way, you will get that you are going the wrong way, or if you are the right way, you will get the message that there's a vehicle going the other way. So some future considerations if you would like to implement this technology: explore funding opportunities. As John mentioned, there's different ways that you can get funds for this type of systems. Identify conflict areas, study the potential locations, get a vendor demonstration if possible, and get a pilot test for that technology and share results and lessons learned. With that, if you ever have any questions regarding this presentation or technology, feel free to reach out and we are helped to help you to save lives. And now we can open to questions.
All right. Thank you, Jessica and John. Got a couple of questions here. The first one's from Josh. Jessica, this is probably earlier on in your presentation. Are these costs per ramp, i.e. multiplied by 2 for a diamond interchange? I'm guessing the cost that actually put the equipment up at the intersections.
Yes, so this is per site. So if you have a diamond intersection, probably you will need two sites. So this is per site. Yeah.
All right. Another question here from Josh. I've seen research that intoxicated drivers are more likely to be looking at the pavement or very low to the ground when driving. A simple countermeasure is mounting wrong way signs lower. Was any consideration given to any of these case studies to doing this in addition to all the flashing red beacons?
Not that I'm aware of. Are you aware of any, John?
Yes. TTI did research on our first project that we did on 281 years back, and they've actually done additional research where they actually took people at their test site up there in College Station, and they put an eye tracker in vehicles and actually got people drunk up to, I think it was 0.12, and they tested them, and those results did show that intoxicated drivers are looking down at the pavement rather than anywhere else generally. Unfortunately, we know from practical experience here in San Antonio that when the drivers are intoxicated, the ones that we've stopped here in San Antonio that we know about in talking to SAPD, they are twice the legal limit. Some of them are much more than twice the legal limit. Excuse me. And we know that those people that are that intoxicated, that unfortunately, even if you put flashing signs that could be lowered, if they're twice the legal limit or more, that may not really do a lot to get their attention just because they are so intoxicated. We have several stories of PD following wrong way drivers on the highway with their sirens going, with their lights on, with their spotlight, with their PA, and the wrong way drivers keep going with a police car right next to them, doing all those things, trying to get their attention. So unfortunately, when people are twice the legal limit or more, the research shows, and we know from practical experience, sometimes there is not a lot you can do to get their attention, unfortunately. But as I think what Jessica showed with her videos, you see a lot of people self-correcting, those people that are not intoxicated, and the flashing beacons of whatever type seem to work very well for people that are paying attention.
Yeah, and just to add to that, NTTA added the flashing RPMs on the payment for that reason. I know that Texas probably needs some approval to install that, but they did that for that reason. Okay. Next question.
I have just a question for you, Jessica. I noticed that the NTTA put the wrong way detection equipment on their ramp, but they chose not to do it on the Houston portion of that roadway. Do you think NTTA would be willing to do that for the city street as well? Because it'd be just as dangerous if a vehicle was going the wrong way down a city street as it would be for a highway like the tollway.
Yeah, I think that's a question that that NTTA will need to answer. I know they're testing the site right now, and if they are happy with the results, and probably you will see more sites with this type of equipment, and maybe they can explore other options.
Okay. And if anybody has any other questions, just go ahead and type it into the chat, and I'll make sure to read it before we leave today. One more from Josh. The message of the in-vehicle alerts by the TAPCO seem like they potentially confused the right-way drivers into thinking they're going the wrong way. This could compound the problem by turning right-way drivers into wrong-way drivers. Have those messages been tested for proper interpretation? I guess that goes to either Jessica or John.
This is John again. I'm going to give a big plug here to anybody that knows Melissa Finley up at TTI in College Station. She's done a lot of research on everything that we've done here in San Antonio, the wrong way driving. She's continued to do that, going into the connected vehicle and autonomous vehicle, and specifically to this question. That is an issue that I don't think has an answer yet, because when we were talking about that, Jessica showed the two images that would pop up in the cars, and there has been research done as to what message you put up to the driver that's actually going the wrong way, and what message you give to that car that would be the person would be approaching a wrong way driver. So that is a question. Like I said, I don't know that there's an answer yet, but if any of y'all know or want to know anything more specifically, I would definitely get a hold of Melissa Finley there at TTI in College Station, and she could probably update you with the most recent findings on that question.
Okay. I have another question here from Ting Ting. Elaborate on what a connected vehicle is. I'm sure, I don't know if either of you would like to explain it or.
Yeah, connected vehicles is well, it can be a lot of things, but mainly it's vehicle talking to the vehicle next to it, in front or to the back. So they're communicating to each other. But also connected vehicles can be the vehicle talking to the infrastructure. So if you are heading a traffic signal that it's going to be red, your vehicle will know that you will hit in a red. And in this instance, for the runway driver, if you are the right way, as John was talking about, you will get a message in your car saying that there's a runway driver, be careful. So that's in a nutshell, what's the connected vehicle arena is.
All right, we're reaching the bottom of the hour, so we've got one more here from Omar. Do police agencies get notified after every incident, and does the system provide the officer any identifying information that would assist in tracking down that motorist? I guess whether the NTTA version or the SA or the San Antonio version.
Jan, do you want to answer that?
With San Antonio, we do not notify SAPD. I know that the TAPCO system has that capability. The traffic comm system that we have also has that capability. It just depends on who you want to notify when you set your system up. Most of the very sophisticated wrong-way driver detection systems now have that capability where you can notify police. You can post messages directly to DMS signs out on the roadway. It just depends on what you want. Now, as far as information for the vehicle, you would have to, I guess, kind of manually do that. I don't know how the detection system would tell them exactly what the car is. The most important information is the vehicle's entry point, the roadway, the cross street, and the direction it's traveling. That's the most important information that police can get.
All right. And I think that will be our last question. I want to thank both John and Jessica for making this presentation here. Pam, do we have anything else that we need to go over, or are we going to be done for the day?
Trying to turn my camera on. We are done, but just wanted to quickly mention that we did record the session, so we'll be uploading the recording, the PDH sheet, and the presentation. We have the presentation from Jessica, so we'll be uploading all that on the Dallas section website. Thank you again to the speakers. Thank you so much for preparation and your time to do this today. And we look forward to seeing everyone in December. So thank you.
Thank you. Bye.
Thank you.